Hello, good evening, everybody. My name is Muhaimin Dzulfakar, and today I'm going to give a presentation called Advanced MySQL Exploitation. So basically, it's about how you can conduct a remote code executions on the MySQL platform. Here a brief introduction about myself. I'm security consultant for securityassessment.com. We are a New Zealand-based company focused on penetration testing and security research. I'm sure most of the people in these rooms have a clear idea about SQL injections. So basically, it's a conditions where we can manipulate SQL statement through the applications. Normally, SQL injection is used to view, delete, and modify database data. In some cases, it's possible to conduct remote code executions by attacking this type of vulnerability. So stack queries are conditions where multiple SQL statements are allowed, and normally they are separated by semicolons. And stack queries has been widely known to be abused in writing a file on the database server. In the Black Hat Europe 2009, Bernardo Demoli demonstrated how remote code executions can be performed on the application that do support stack query. And this technique has been implemented in his tool called SQL Map. And today I'm going to demonstrate how we can perform a remote code execution on the application that do not support stack query. So here is an example of how stack query can be abused on the MySQL platform. This technique is known as the UDF injection techniques. However, it only works on the MySQLs with the ASP.NET application. If you look at the stack query tables, on the top we have all different type of applications, and on the left side we have the different type of the databases. As you can see in these tables, there are only two applications that do not support stack query by default. They are known as ASP and PHP. So what we're going to focus today, we're going to focus on the MySQL PHP. As we all know, MySQL is widely used with PHP, and they are part of the software stack for LAMP and WAMP environment. So traditionally, a simple PHP script is used to execute commands on the web server. So we can just simply execute command while we need more reliable shells. A good example is metasploit shells. So metasploit shell is a powerful shell that can be used in post-exploitation process. We can use metasploit shells to conduct token impersonations, attack to escalate privilege from a local system to the administrator user. And another good example, if we want to have a graphic user interface access on the web server, we can just simply use VNC shells. And all these shellcodes can easily be created using a metasploit framework. So here are some basic techniques in reading and writing file on the MySQL PHP platform. So basically, we use select load in file to read a file on the database server, and we can use select into art file or dump file to write a file on the database server. And the next one is a technique can be used to conduct a remote code executions on the MySQL PHP. So basically, what we can do is we can upload compress arbitrary files on the web server. And then this file can be compressed back to its original size before it being executed using a PHP system function. So if the application do not support stack query, the only methods to write a file is through the union select. And here are some challenges in writing arbitrary file to the union select. First, the GET request limit us only up to 8,190 bytes on Apache. And also the data for the first query can override our file header. And also Data from the extra column can add unnecessary data into arbitrary file, and this can potentially corrupt our file. So I'm going to explain how we can fix all these problems. So to fix the URL length issue, we can just simply use a PHP zlib library to compress our arbitrary file. So in my experiments, from 9,625 bytes, I was able to compress my file up to only 635 bytes, and this was able to bypass the maximum limit allowed by Apache. And this file can then be compressed back before it's be executed on the destination. Union select also will combine a result from the first query and the second query. And most of the time, you will find that the result from the first query will override our file header. So to prevent this from happening, what can we do? We can inject a non-existing value in the where clause to force the application to return empty data. If you look at these examples, question equals 169 will return us string defcon, and this will override our file header. So to prevent this from happening, we can just simply inject a question equal to any non-existing value from a database. And then after the union select, you can see that is our executable code. Okay, fixing the column issue. So in the union select, the second query required the same amount of column of the first queries. And in some cases, you will find that you need to inject some unnecessary data into some of these columns. So to prevent data corruptions, our arbitrary file needs to be injected in the first column. This is because the zlib uses an adler32 checksum, and this value is added at the end of our arbitrary file. In the IRC, it is stated that anything after this value will be ignored during the decompression process, so we can just simply abuse this functionality. Another method can be used is by splitting our arbitrary file into the amounts of columns and inject this data by sequence. So here is one example that I have here is it's required 3 columns, and what I did, I injected all my compressed arbitrary file in the first columns, and then you can see there are 2 null bytes being injected on the second and the third column. And this file has no issue when we decompress it using gz uncompressed function. Remote code executions on LAMP has one limitation. So basically, a file created in Linux is not writable by default. But in some cases, you will find that this directory required to be writable. Good examples of this in the application that user is allowed to upload contents on the web server. And also, the file created through the select into dump file is not executable by default. But this is not an issue because we can just simply use the PHP to read the same file contents and write it back to another file. And then this arbitrary file can be executed using a PHP system function. Remote code execution on the WAMP has less limitation and constraint. This is because MySQL on Windows by default run as a local system, and this user is allowed to write anywhere in the web server directory. So we can just simply write our arbitrary file in one of the web server directory and then use the same methods that we use for the LAMP to execute this file, which we use a PHP system function. So what is MySqloit? MySqloit is a tool that I wrote as a proof of concept to demonstrate how we can conduct a remote code executions on the MySQL PHP platform. MySQL contains a few different modules. They are known as SQL Injection Detection modules, Fingerprint Directory module, Fingerprint OS, Payload, and Exploit modules. So now I'm going to demonstrate how I can use MySqloit to upload and execute metasploit shellcode, and how we can combine all these modules to perform remote code execution. So now I'm going to test on the first module. So basically, our SQL injection detection module use a deep blind injection technique, which is known as a timing attack. So if you can see here, when I test the applications, as you can see here, SQL injection is successfully discovered, and it contains only one column. And then the second module is the fingerprint operating system module. So basically, MySqloit use a load in file method to try to load a file, default file on Windows and Linux, and try to differentiate whether the backend operating system running on Windows or Linux. Sorry? You can see the bottom part or on the top part? The bottom part. Okay. Sorry about that. It's all good now? Yeah, sorry, I can release the actually. Oh. I think it looks fine now. Okay, sorry about that. Okay, so now I'm going to test on the second module, which is known as fingerprint operating system module. So, oh, I think I tried that module before. Okay, so I think, sorry? You want me to? Okay, cool. So I'm going to start everything back again. Sorry for the inconvenience. So I'm going to try on the first module. So first module is known as a SQL injection detection module. So basically, it uses a deep blind injection method, which is known as the timing attacks. Okay, so now you can see there is SQL injection is successfully been discovered, and it's only one column required. And then the second module is a fingerprint operating system module. So basically, it uses a load in file method by loading a default file or the Windows or Linux. And by doing that, it can identify whether the backend operating system is running on Windows or Linux. Okay, so now you can see that the backend operating system is running on Windows. And the third one is a fingerprint working directory module. So basically, this module uses two different methods. The first method is called the error message method. This is done by injecting a bogus data as part of the SQL query, because normally the PHP application will return us an error message, and this error message contains sensitive information about the working directory. And then the second method is known as a load in file method. So this is done by loading a default configuration Apache file, as this file also contains sensitive information about the working directory. As you can see here, the first method was not successful. And then what MySQL did is try on the second method and try to load a default configuration of Apache files. And as you can see here, here is the web server directory. So we can just simply copy the information, as this is required as part of the arguments in the exploit module. And now I'm going to create a metasploit shellcode. So basically, a payload module is integrated with the fingerprint operating system module to create a suitable payload for the operating system. So in these examples, I try to create a bind shellcode on the port 7777. So as you can see here, our metasploit shellcode successfully been created and binds on the port 777. And now is the last module, is the exploit module. As you can see here, here's our argument required to exploit it. So basically, we can just simply put our reverse back shellcode, port 777, and the working directory. This information's we had from fingerprints working directory modules, and then a writable directory. So as we know, it runs on the WAMP environment, and the working directory is not required, as we know the MySQL runs as a local system, and we'll be able to just simply upload anywhere in the web server directory. So in this case, I choose a root directory for a web server. And now you will see some bunch of a compressed arbitrary data being uploaded on the web server, and then this file will be decompressed back to its original size before it is executed through the PHP system function. And our metasploit listener is binding on the port 777 and it's waiting for a connection. And now you can see our VNC shellcode is successfully executed on the web server. So that is all for my presentation today. If you have any question, you can just see me after the presentation. Thank you very much.